Okay, class. Okay, now turn to objective questions. Paper 1, page 87. Okay, so let's look into this question. Okay, the table shows the proton number. Okay, proton number. So can have a look. Okay, if you are given the proton number, okay, first thing you need to do, okay, I suggest you to do is write out the electron arrangement. So this one is 21, 281, sorry, 283. This one is 24. This one is 2x7. Okay. So all must know how to write it correctly. Okay, so here we can see the group. Okay, so this one is group 1, this one group 13, group 14, this one group 17. So these two are non-metal. Right? These two are metal. Okay. So let's see which of the following pair form a compound that is insoluble in water. So class, insoluble in water refers to what type of compound?
Ionic.
Ionic, insoluble in water? Sure.
Oh, sorry. Ever. Covalent.
Covalent, huh? Okay. So covalent compound. So which one will form a covalent compound? Yeah. So metal will be out already, right? W and X. So you got W1 out of X also out. W out. So only C, Y and Z. Okay, then. Okay, next. Okay, this one also the same. Same techniques to answer the questions. Okay, so all these out the proton number, right? Okay, so you can list out the electron arrangement. So which pair form a compound that can conduct electricity? Okay, so what type of bond here? Or what type of compound can conduct electricity? So you refer to what? Page 88, I think. 88. Okay. So can conduct electricity in aqueous. So what is this type of compound here? Ionic, yes, ionic. So which one is ionic? Ionic must be metal with non-metal. Okay, so which one is metal, class? We find out first. Which one is metal? This one, right? 281. Okay, so why? Non-metal, this one 2x6, this one non-metal. Z, this one 27, also non-metal. This one 24, also non-metal. This one 1, hydrogen, also non-metal. So let's see if Y must have Y. Only one got Y. So X and Y. Hanya satu saja yang ada Y. Okay, yeah, X and Y. Okay, so let's say coming exam, if this kind of question coming out, you must know how to answer. Okay, so silicon dioxide is called what, class? What we call it? It's under covalent, right? It's under giant, giant covalent compound. Okay, so which of the following true about this molecule? Okay, so which one is true? Okay, small and simple structure. No, it's a giant one, it's complex one. So if here simple, no, out already. Okay, no van der Waals attraction force exists in the molecule. Yeah, so correct. Van der Waals between molecules are weak. Okay, so this one is special because of the giant covalent bond you see. Actually, this one is one. Sorry, this one is one covalent. If simple one, simple one. Okay, this is the one covalent compound. But if they combine with others, Okay. Then it will form a giant one, like silicon dioxide, like diamond, all this. Okay. It will form like if extend it, you will become like this. Okay, a lot of carbon compounds and so on. Okay. So meaning that inside the molecules here, there will be no attraction force. No van der Waals force attraction. Okay. This one is van der Waals. This one is for the simple covalent bond. Okay, simple covalent bond. Okay, let's say carbon dioxide. Okay, like this with another one. Then here got the covalent. The bond should be in between here. Okay, covalent bond. Okay, yeah. So covalent bond. Sorry, the van der Waals force is weak. Okay. So the answer is B. B. Okay, next again is a giant molecular structure. Okay. Property. I think should be simple, no high melting and boiling point, strong covalent bond in molecules, and weak force of attraction between the molecule. I think not C. The answer. Okay. I think the answer should be B, not C. Okay, it has a very high melting and boiling point. Okay, because of the attraction force is very strong. Okay, because here weak force between the molecule, no. This one, no. This part is still okay, but this part is wrong. Okay, I will double check again. If I'm wrong, I will let you know in the class. Okay, now this. Okay, this one is a simple one. This one simple. This one is giant. As long as you see the structure like this, this one is a giant one. Okay, so which one is true? Okay, so this one simple. Simple. Okay. Weak covalent bond. No. Covalent bond here should be strong, not weak. Okay. So it's still strong actually. Strong also. Okay. This one also strong. So this one is wrong. Cannot conduct electricity. Yeah, cannot conduct electricity. This one also cannot. Cannot. Because why? Why cannot conduct electricity? Yeah, class. Anyone can feedback? Why cannot conduct electricity? A standard answer, as long as you see this. What is the standard answer? Anyone know? Yeah, class.
What you cannot conduct? Why cannot conduct?
Yeah. Why cannot conduct electricity?
No free moving ion.
Yeah. Our standard answer, no. Really moving ions. Okay. If you see this question, why cannot conduct electricity? So you just use this standard answer, or it consists of molecules only. Yeah. Low melting point. Okay. This one correct. Low. This one correct. But this one low is wrong. Should be high. Okay. Then van der Waals, yes. Okay. This one no. No van der Waals. So D. Yes. Okay. Now this. What is this class? Insecticides. Racun serangga. Okay. So let's see. Inside here. Okay. Plus, what is this? bond. What is this bond? Any idea? If in this chapter, right, we learn the main two types of bond is ionic and covalent. So this one is referred to ionic or covalent. Covalent. Okay, so it's a covalent. So which one is the characteristics? Okay. Soluble in water? No. High melting point? No. Low. So this one should be insoluble. So volatile easily. Why volatile easily? Okay. Class volatile means what? Merod. Merod is what? Liquid. Change to gas. Okay. Why it can change to gas easily?
Is it because of the low melting point
Okay,
and
so,
boiling point?
here, if liquid to gas, it will be low boiling point, right? Okay. If solid to liquid, then will be melting point. Yeah, correct. Correct. So it has low boiling point. So it can change to gas easily. Okay. Okay, good. Next, which of the following substances will undergo chemical changes when electricity is passed through it? Okay. So this one actually under Form 5, the electrochemistry. Yeah. But here actually we can relate it to what we learned in the chapter 5 here. Okay, so which one can conduct electricity, class? What compound? Can conduct electricity? Yes. It is referred to ionic compound. Okay. So ionic compound, why? Because it has ions and it has anions. Okay. Positive ions, this is negative ions. Free moving ions. Then which one is referred to the answer here? Which one is ionic? Naphthalene, covalent, right? So out. Glucose, also covalent. Okay, lead to bromide. Lead to bromide is ionic, right? Okay. In the solid, can it undergoes chemical change? Can pass through or not in a solid state? Ionic. Cannot, right? If molten lead to bromide, yeah, it can. Oh, can if molten. But here, because of solid, so cannot. No? Because the ions cannot move freely. Move freely. Okay. Then solution, yes. If potassium nitrate solution, then yes. Because in the solution, then ions can move freely.
Teacher.
Hmm.
How is ionic bond looks like?
Ionic bond looks like it's just the attraction between the positive and negative ions. Okay, attraction between the positive and negative ions.
Oh.
Yeah, let me show you in your notes.
Because I found the covalent bond only.
Okay. Ionic. Okay, chapter 5. It does not show it to you. Just draw out like that only. Let me see. Oh, not it. Periodic table. Okay. Ionic bond is just it does not show any bond here. Okay. is a strong electrostatic force between the positive and negative ions. So this electrostatic force refers to the ionic bond. Okay. Then if we want to see, it would be something like this. Let me see here. Oh no, not drawing out right. Okay. Actually, is if we want to draw, but don't worry, it won't ask you to draw. It will be something like this. Okay. Let's say I use the sodium chloride. Let's say it will be like this: sodium. Then it will combine with chloride. Then this one's chloride. This one's sodium. Then this one's sodium. This one chloride. Something like this. Then also can combine like this. Okay. Then it will form a very huge structure like this. Okay. And so on. Something like this. Okay. But to make it simple, we just assume it is between the positive and negative ions. This is the ionic bond. Okay, huh? Class?
Okay.
Okay. Next. Okay, do experiments. Solubility. Sodium chloride in water and metabenzene. So class, what is metabenzene? Is organic solvent, no? Remember, huh? Okay. So whenever if let's say you forgot already what is organic solvent, means quickly you go back to chapter 5 and then go through what is organic solvent. Okay, it shows the apparatus to show the electrical conductivity. Yeah? Okay. Now here, sodium chloride in water. This one's in methylbenzene. So this one, is it lights up? No. This one lights up, right? Okay, so this one lights up, this one cannot. Okay. So class, what is inside here? So that the bulb can lights up. Yeah. Why it can conduct electricity? This is ionic compound, right? This one also ionic compound. Here it has freely moving ions, meaning that it can ionize or dissolve in water to form freely moving ions. So ions can move freely, then it can carry the electrical charges. Okay. This one in the methylbenzene. Okay. So does not ionize. Okay. So at fixed position, ions cannot move freely. Cannot move freely. Okay. So what is inference? What is an inference? Inference explain the observation. Okay. Why it cannot conduct electricity for B, but this one can conduct electricity? The bulb lights up, right? Okay. So sodium chloride exists as ions in water, exists as molecule in water. Sodium chloride is ionic, right? So ionic never has the ion molecules. Molecules is only for covalent. Okay, so remember covalent got the molecules. So sodium chloride exists as ions in methylbenzene. No. Okay. It has ions, but it cannot move freely. Okay. So cannot ionize. So exists as ions in a fixed position. Okay. It is not molecule. So to be specific here, ions in fixed position. Okay. Meaning that it cannot move freely. Atoms also wrong. It is ions but cannot move freely. So A. Okay, next. Correct image. Okay, limestone, table salt. Okay, acetamide, silicon dioxide. Which one is correct? Limestone is what class? Yeah, class what is limestone? Anyone can find? Calcium what is under calcium, right? Limestone. Yeah. Calcium carbonate. Okay. Calcium carbonate. Huh? So is what type of compound? It is under ionic, no? Right? So not covalent. Okay, table salt. What is table salt?
NaCl.
Yeah. Sodium chloride. Okay, sodium chloride. What is the type of compound? Also
Covalent
ionic, right?
compound.
Ionic. Oh.
Salah.
NaCl. Okay, acetamide. Acetamide is covalent, not ionic. Yeah. And silicon dioxide is covalent. Okay, so only D correct. Okay. Now next. Okay. G, good heat and electrical conductor in a solid and molten. So class, if can conduct electricity in a solid, what is that?
Metallic bonds.
Yeah, only one. If solid can conduct electricity, will be metal. So if metal, will be metallic bond. Okay. Tak payah fikir banyak. Okay, next. Which of the following statement correctly describe why solid sodium chloride cannot conduct electricity, but molten sodium chloride able to conduct electricity? So, what is this? One is in the solid, but one is in the molten. Just now I explained already. What is that? Same concept, right? Okay. Freely moving ions. Okay. Okay. Then in the solid, cannot move freely. Yeah. Then in molten, can move freely. So cannot move freely. Solid, cannot move freely. But can move freely when melted. Molten is melted. Molten means you heat until melt. Okay, so BC no need to see. Okay, so chapter 5 finished already. Okay. So more important is the formation. You need to know how to form the ionic and covalent bond. Explain correctly. Okay. Now we go to chapter 6. Okay. Chapter 6. Okay, we try a few objectives, then we go to this paper 2. Okay, now role of water to show the acidity or acidic properties and alkaline properties. So which of the following is acidic? Acidic. Okay. So class ammonia. Ammonia, remember, is weak alkali. Okay. Potassium oxide, what is that? Metal oxide is base, remember. And sodium hydroxide is alkali, strong alkali. So only one, carbon dioxide is acidic. Okay. Next, which ions is produced when hydrogen ions combine with water? This one, who still remember? Normally in the acid, we just say it's a hydrogen ions, right? Okay, simplified form, this one. But actually, what is that? Hydroxide? No, but hydroxide is for the alkaline. Okay, hydrosodium. Okay, you should be able to write out the equation. Hydrogen react with water. Okay. Your forms of hydrosodium is H3, or positive. This is the hydrosonium. Okay, and then hydrosonium is what type of bond? Still remember? Under dative bond. Okay, dative bond, remember. Siapa sudah lupa, tengok balik. Dative bond only two. One is hydrosonium, another one is ammonium. Two only, so hydrosonium is one. Hydrosonium under here is not asking you about the bond, it's asking you about the hydrosonium. Hydrosonium is the simply, you can write this one, you also can write the hydrogen ions to show the acidic. Okay, so hydrosonium. Okay, now which of the following character hydrogen chloride gas that enables its acidic properties to be shown? Okay, so how the hydrogen chloride in a gas form to show the acidic properties class. Best answer, remember, you must choose the best answer. Ionized in water, this one is correct, but let's see. Got other more accurate or better, more suitable answer or not? Okay, dissolve in water. It dissolve in water, but ionized actually is better. Dissolve also correct lah. Okay. Contains hydrogen ions in its molecule. Okay. No, not if like this, it also cannot show the acidic properties. So this one confirm out. This one not very suitable. Okay, ionized in water, same as A, and produce a hydrogen ion. So this one is better. Okay. Remember, if want to show the acidic properties, it must have the hydrogen ions. Okay. Okay, next class. Okay, next. Another few questions. Okay, which of the following is the correct terminology for the chemical substance that ionize partially in water? Okay, if ionize partially in water, so we know already it's under weak, right? But weak what? Low concentration of hydroxide. Yeah, if hydroxide ions is under alkali, right? Weak alkali. No? If weak acid, it will be hydrogen ion. Then it will be weak acid. Okay, ionized partially. Okay, so in experiment, them. Okay, what is mean by them? Them. Lembab, lembab means it has water already, or moist. Sometimes you will see the word moist. Means already got water. Okay, it turns red when insert into a set of tube containing gas X. Okay, so blue turns to red. What does that mean? It is acidic, right? Okay, acidic. So which following is correct? So which one is showing the acidic? Dissolve in water and ionize to form hydrogen ion. Yeah, this one correct. Let's see. High concentration of hydroxide ions, so hydroxide ions wrong. Produced from the reaction between acid and alkali. So what is this? This one is the salt. Okay. So salt is neutral. So it won't change the red number spectrum to blue to red or red to blue because it's neutral. Okay, so the answer is A. Okay, now why does the ammonia able to show its alkalinity in water? Okay, same alkali, right? Dissolve in water to form ammonium ions and hydroxide ions. Okay, less dense and gas are not related. Okay. 3 hydrogen atoms per molecule? No. Because if we want to, we just focus it to alkaline properties. alkaline, you must have the hydroxide ion, right? Having free electrons pair the tip bond with the water molecule. No matter how it does not show the hydroxide, then the answer is wrong. Dissolving water, yeah, dissolving water, but no hydroxide. So only one give us the answer. So only A. Correct. Okay, first. Okay, so I think for paper 1, we discuss some CO here. We go to paper 2. Okay. Okay, for this, I think a lot of question is the essay part of essay, okay, which is good. Okay, but this one is a structure. Okay, diagram shows the steps for the preparing of the standard solution. Okay, sodium carbonate, sodium carbonate. Okay, so first we measure the mass, right? But before that, you need to calculate first, right? Okay, then put the solid X gram into the beaker, right? Then put in sufficient of water, distilled water, then stir it. Okay, then you transfer it into this volume. Depends to what volume we want. You want to 1,000 ka, 5,000 ka. Okay. Then after that, remember this volume, this distilled water used must be less than 250. Cannot be, you want to prepare 250 ml. Here you put 500 ml. Cannot anymore. Must be less than that. Otherwise, once you put in, the overflow already. Okay. Let's say here you put 200 or 100, as long as can dissolve all. Dissolve all the solid here. Okay. The solid X gram. Then transfer all the solution into it and then use the pipette. I think not the pipette. This one should be. What is the correct one? Do we use the pipette? Dropper, yes, should be dropper. So this one wrong, make the correction. Then, okay, drop it until the calibration mark here, the level here. So it is 250 ml. Okay, then stopper it and then invert it few times. Okay, then you get the concentration 0.05 mole per cubic decimeter. Okay, now if we work it towards reversely, what is the X? Okay, right? Later, I think the question definitely will ask you. Okay, first definition. Okay, what is meant by standard solution class? I think coming exam, most likely I will ask this question also. Late question already. Yeah, what is meant by standard solution? Okay, I quickly go to search. Okay, standard solution. Got it? Okay, which page? Buka surat berapa? Anyone found it? Buka surat berapa? Which page?
113.
113. 113. Okay, thank you. Everybody refer to here. Okay, online one can refer, but sometimes you have to refer to our syllabus one because sometimes the online one is I cannot say they are wrong, not fulfilling the needs of the marking scheme. Okay. So it is a solution with non-concentration accurately. Okay. Okay. You refer to page 113, I think. Should be no problem. Okay, give one reason why this method not suitable to prepare standard solution of sodium hydroxide. Okay. Sodium hydroxide is not very suitable. Okay. Why? Although the example given in your notes there is sodium hydroxide, right? Actually, previous version of the textbook also used the sodium hydroxide, but now no more like actually use the sodium carbonate. This is the one. Okay, why sodium hydroxide cannot? Because it is hydroscopic. Okay, class, what is mean by hydroscopic? It means it can absorb water in the air. Okay, absorb water in the air. Okay, meaning that once you put it there for a while, then the surface of the sodium hydroxide looks like already turns to liquid a bit lah. Macam sudah jadi cair lah, because it absorbs the water from the air. Okay, so because it is hygroscopic. Okay, spelling not hygroscopic. Hygroscopic. Okay, next. Calculate the value of X in gram. Okay, used to prepare the standard solution. So what is the mass? Okay, here you have the concentration, right? So class concentration is what class? It's the M, right? Okay. What is the V? Volume. What is the volume class? So I look into this volumetric class, right? Here, right? 250. V. 250. So if you have M, you have V. Can you find the number of mole? Definitely, right? Okay. So you find the mole first. Okay. Find the mole. MV over 1000. Okay. So you can find the mole. So everybody you try. What is the number of mole? Berapa? MV over 1000. You look at your own book lah, Ahmad. You have the book, right? Also not clear, right? Which page? Anyone tell us what page is that? Muka surat berapa? Okay, thank you. Hello, 113. Okay, so hello sudah kira berapa mau? Anyone you have calculated already? Okay, 0.0125, correct enough. So M is 0.005, is it? 0.05. Okay, V is 250 over 1000. So use your calculator. I think, yeah, 0125. Correct, no, class? Okay, correct. Now you have the mole. Can you find the mass? Yes, right. Okay. So you have mass, the mole times the molar mass, right? Okay, molar mass for sodium carbonate. So use the, what is the molar mass for the sodium carbonate? Mole is 0.0125, right? Molar mass.
Không chị,
0.5.
please. Ali.
Okay, so molar mass, sodium carbonate, your formula must be correct. Sodium carbonate. Right. Twenty-three, 46, 12, plus 48. Sorry. Yeah, 48. Okay, 48. 1.325. Okay. Yeah. So meaning that you get 1.325. Okay, let's check. Yeah, correct. Okay, good. Ivan. Meaning that in exam, if you can calculate all this, then you can score very well, including in essay also like this. Okay, maybe part of it. Just a minor thing like equation must be, or formula must be correct. If your formula wrong, then your answer here definitely is wrong. Okay, then? So correct. Okay, MV over 1000, so 0.0125. Okay, correct. Molar mass, you have to show. This one can unit mesti ada juga. Unit. Okay. More. You must show it. Okay. Okay, good. Yang lain pun dapat. Okay, now next, write the chemical equation for if the titration is carried out using the sodium carbonate and hydrochloric acid. Okay, so this one actually titration for neutralization, but somehow this one sodium carbonate react with hydrochloric acid. Okay, so this one is a metal carbonate, alright. Okay, metal carbonate with acid. So what is the product class? Metal carbonate with acid. So you produce what? Produce salt, carbon dioxide, and water. Correct. So sodium chloride, water, carbon dioxide. Okay. These two location can be exchanged. Okay, just need to balance it. So 2 marks. All formula correct. So 1 mark. Then balance 1 mark. 2 marks. If one of the formula, let's say this formula wrong, then 0 mark. Okay. So make sure that your equation must be correct. Okay, class. Okay, next. This one is a structure. Okay, we try one essay. Satu essay. Yeah. This. Okay, MRSM. Okay, which page is this? Anyone can tell us? Hydrologic, page 93. Yeah. Cairo, you means Cairo, you ask, can I write hydrochloric acid first, right? Then this one later. Yeah, can you can exchange as long as reactants and the products position doesn't matter. You can exchange. You can write water first. You can write carbon dioxide first or sodium chloride first. Position doesn't matter as long as it's under products. Okay. Okay. Now we look into essay. Essay. If the space is not enough, then you need to get a foolscap paper. Oh yeah, for exam, right? Coming exam, the foolscap paper, each student you give three foolscap paper. Okay, let's staple together. Okay, then class, another one I want to remind you here is after you done your essay, right? Okay, you staple together with your question paper. Understand? Huh? You staple together with the question paper. Okay. I don't want to. Your essay is split from the question. I want them to be together. Okay. So class monitor, you remind them again. Okay. Now we look into this flow chart to investigate the property of gas M. Gas M. So we don't know what is that. Most probably is acid. Okay, because alkali no sample of the example for alkali. Okay, so flow into propanol. Okay, into propanol. This one into water. Okay, so propanol is what organic solvent, right? So it forms a lambda Q solution Q, some solution P. Okay, then put in a universal indicator. Okay, this one turns to blue. Okay, this one turns to green. Universal indicator, gas M. My prediction just now is wrong. Okay, now universal indicator. Okay, I try to search universal indicator. Universal indicator. Okay, so look into images. I use this. Macam tipu saya macam ask me to go in here. Nothing. Yeah, nice. Hey. Why? Okay, not enlarge. Okay, now we have a look here. Okay, so if green color, okay, green color is neutral. Okay, so then if it is blue, meaning say it's alkaline. Okay, alkaline. Then if it is lighter or yellow, green, light green, yellow, red, this one is acidic. Acidic. Yeah. Okay. So we go back to our question. So meaning say if blue means what? Alkaline, right? This one is neutral. Okay. So class, what is this gas M? What is the property class? Alkaline, yes. This is alkaline. Okay, alkaline. Then why in the propanol it cannot show it still show it is neutral? Why? In propanol, why it cannot show the alkaline properties? Yeah, that is a conclusion, Cairo. It does not show the alkaline properties. But why? Okay, so all this you need to know how to explain. You see 5 marks, how to explain? Explains the difference in the observation. Okay. Cannot hydrolyze. Okay, one by one. Pyro, we cannot hydrolyze in organic. We don't use the word hydrolyze. We use other words. Liver. Liver say got acid, no? No. Here is not related to acid, no? Ada pelajar yang kata mungkin, oh, ini alkali, dia tambah dengan acid neutral, right? But here it doesn't mention that if it pass the acid. No. But it's only mentioned is the propanol. Yeah. Okay. Yeah, Charlene. Does not ionize in propanol. Yeah. Correct. No? Does not ionize in propanol. Meaning that what is the particles in the propanol? It still exists as molecules. Molecules. Okay, so I like to draw your attention to our revision in the early of this chapter. I already mentioned in the class with you. Okay, the concept is very simple, but student don't know how to use it or don't know how to explain it. Okay, everybody, you can turn to page. Let me see. Yeah, here. Page 102 class. 102. Okay. Actually, you can see in exam, they always use the same example. Meaning that this X can be example as ammonia because ammonia is weak alkali. Okay. So dissolve in propanol, right? This one dissolve in water. So these are the things that you need to explain. Okay, does not ionize, right? Cairo, yes, just now you mentioned already. Ionize, not hydrolyze, ionize. So, as still exists a molecule only, no hydroxide ions is present. So you have to mention these 2 points. How many marks? 5, right? So there are no hydroxide ions, right? So it cannot change the universal indicator to blue color. So it just shows universal indicator is green color. Okay. But in the water, so it ionizes partially to produce the hydroxide ions. Okay. Then it can, hydroxide ions are present, so it can turns here is used the lemon pepper, right? But universal indicator to blue color. Okay. This one does not change, turns the universal indicator to blue. Okay, so 3. You need to mention this. Okay. So hydroxide ions is present. So page 102, yes, correct. Okay. So always refer back to your notes if you want to explain, especially if you're still not very familiar with the answering techniques. You can always, so 5 marks. So here already got 6 points, right? Just now what we mentioned here. Okay, so you write these 3. But this one you change the red lemon pepper to universal indicator. Okay, this one you have to change. Okay, here got 6 points already. So confirm is enough to get 5 marks. Okay, I'm done class. So this is how we can score in the essay. So I hope you all get familiar with it. Okay, the more questions we discuss, then you will be able to answer it correctly. So in coming exam, almost the same like this. Okay, so show the pH value of alkali Q and R. Okay, this one pH 10, this one pH 13. Same concentration. Okay, so suggest the name of the Q and R. Okay, what do you think? pH 13. What is this? Example. pH 10. This one means a weak alkali, right? This one is strong. So example, directly give example, right? Suggest the name. Cannot use formula, must be the name. Okay, also 5 marks, right? 5 marks. Okay. Also got in our discussion actually. pH, right? pH under strong and weak. Yeah. This is alkali acid. Yeah.
Sodium hydroxide.
Okay. For which one?
For the pH value equals to 13.1.
Okay, correct. The other one? Another one, what is the example? Huh? Weak alkali.
Yeah.
Ammonia? Yes, can. Ammonia. Let me see. Okay, you can use this one. Oh, I know already. Under pH. Where is the pH?
H,
Yeah, pH. Where are you, pH?
page 116, is it?
116. There is one part is regarding the pH, right? Is it 116? See that? I want to relate it to the here. Yeah, okay. So regarding about the pH, I'll refer to this page 120, easier. Okay. This is for acid. For alkali, almost the same. So sorry, this is for acid. Now what we want to see is the alkaline, right? Alkaline. Okay. Okay, it's okay. We just relate it to the okay. So this one, sodium hydroxide, okay, or potassium hydroxide also can. Two only. Okay. In exam, just give one. No need to write two answers. Okay, this one ammonia. Okay. Now, class explains the difference in the pH. Like this. Difference. You must mention higher pH, lower pH. Okay. So for this, strong and weak alkali, you just give the definition will be enough already. Okay. So you say Q is what? This one is Q, right? Okay. Q is ammonia. Okay. Okay. Danger. Okay. Then you can mention ammonia is what? Weak alkali, right? Okay. What is the definition for weak alkali? That
Hydrolyzes partially.
ionizes partially in where? In water to produce high or low concentration?
Low concentration.
Low concentration of what ions? Hydroxide ions. Okay. So thus ammonia has a lower pH than sodium hydroxide. Okay. Then you can say R. Is it R? Yeah. R is what? Sodium hydroxide. Okay. So sodium hydroxide is a strong alkali. Okay. So if you can remember this part, then this one is reverse. Ionized one. Completely in water to produce high concentration of hydroxide ions. Thus has a higher pH than ammonia. If you can write like this, confirm can get full marks. Cairo don't use fully. They only accept completely. This one is ionized partially. Okay. So acid also the same. Acid also the same. Ionized partially, then low concentration. But acid is hydrogen ions. Okay. We can use the same thing to apply in the acid. Okay. Okay. C, this one C is under food additives, will be in Form 5, so we can skip now. Okay, but some part we still can do lah. Okay, state the meaning of salt class. We can only do this part only. What is the meaning of salt? Define. It is what? Salt is an ionic compound. It must be ionic compound. Okay, form when what? Hydrogen ions. Hydrogen ions from acid is replaced by what? Replaced by who? By metal ions or ammonium ion. Okay, fix. Hydrogen ions in acid replaced by metal ions or ammonium ions. Okay. So meaning that any metal ions, for example, okay, copper 2 oxide with hydrochloric acid. Okay, these hydrogen ions from the acid is replaced by the metal ions copper. So it forms a copper 2 chloride and water. So this is the salt. definition for the salt. Okay, no? So this hydrogen ions from the acid replaced by the metal ions or ammonium ions also can. So this is a salt. Okay. So the following part, food and beverage, this one under Form 5, so no need. Okay, now here. The heating of sodium sulfide in acidic medium release the gas that change the blue lemon vapor to red. This one 4B, we haven't entered, but never mind. Okay. Describe the method that can use to confirm identify the gas release. Okay. So change the moist blue lemon pepper to red color. Okay. Sodium sulfide. Okay. This one, what do you think the most possibility for the gas to produce from the sodium sulfate is what? Is the sulfur dioxide, sulfur dioxide. Okay, sulfur dioxide. Okay, so 6 marks. How to verify the gas? So we go back to our syllabus today. The list of the gas, right? Okay, the checklist of the gas. Yeah. Okay, so here, sulfur dioxide gas. Bubble the gas through the acidified potassium dichromate 6. Then the orange solution turns to green. Okay, so how to pass it? So now I show it to you. Okay, like this. Manganate also can. Acidified potassium manganate 7 or dichromate 6 also can. Okay, label diagrams. Okay, flow the gas into the test tube containing acidified potassium manganate 7. Okay, or what we learned today is potassium dichromate. Okay, 6 solution. Then the orange solution turns to green. If we use this potassium manganate 7, the purple color it will decolorize. Okay, purple to colorless. If this one, it will be orange to green. So sulfur dioxide gas is produced. Okay, so this one you also can change to this one. Means initially it's orange color. If acidified potassium manganate 7, this one is purple color. Then it turns to colorless. Okay, so altogether, this one 2 marks. Label this part also I mentioned to you, this part cannot be fully immersed, must be a little bit coming out. Solution must be dotted line, cannot be like clean there, must be a dotted line solution. Tak boleh biar macam ini ya. If like this, it will be clear, show nothing. Cannot, it must be dotted line. Okay. Okay. So this is how we can test the gas. Okay. So I think tonight we will end here. Those who finish already, then you can leave. Okay. Yeah. Thank you, class, for attention.